Picture a hotel hallway.
Okay.
It's pitch black, the fire alarms are just screaming, and the ceiling is, well, it's rapidly filling with thick gray smoke.
Terrifying.
Right. And in that moment of absolute panic, you aren't looking for like a reinforced steel beam or a sprinkler valve. You are scanning the darkness for one very specific glowing piece of red or green plastic.
The exit sign.
Exactly. So today on our deep dive, we are looking at the exact instructions that ensure that specific light actually turns on when you need it most. Welcome to the show. We take the most fascinating sources, decode the jargon, and hand you the ultimate shortcut to being well-informed.
Yeah, and today's source material is, well, it's deceptively mundane. We're looking at a dense, single-page installation manual for a commercial LED combo exit and emergency light.
I have to admit, when I first looked at our stack of sources for today, I thought an exit sign.
Really?
Right, it seems so basic.
Yeah, I mean, you pass them in every hallway, stairwell, grocery store. You probably walked under 3 of them today and didn't even blink.
Most people don't. But reading through this manual completely changed my perspective. We're putting on the hard hats of a veteran electrician and a commercial property manager today, because behind that little piece of glowing plastic is this strict, highly regulated world of compliance, delicate wiring, and literally life-or-death procedures.
It really is the ultimate example of invisible infrastructure. I mean, when the power grid fails, that small, cheap-looking plastic box is suddenly the most important object in the entire building.
Well, absolutely.
And making sure it survives that transition from normal power to a total blackout, it requires a staggering amount of technical precision.
Okay, let's unpack this. Because if you start reading through this dense, jargon-heavy manual, the very first thing that jumps out under a massive, bold, important heading isn't about wires or screwdrivers.
No, it's not.
It's a strict rule about time. Like, before you even think about mounting this thing to a wall, the manual demands you understand the battery's life cycle. It states that after electricity is connected, the battery must charge for at least 24 hours before normal operation takes effect.
Yeah, that is the absolute golden rule of emergency lighting. You cannot just, wire it up, see the LEDs glow, and call it a day.
See, I actually initially pushed back on this when I read it, because if you think about buying a new smartphone, right?
Sure.
You take it out of the box, you turn it on, and you can immediately start texting while it charges. Why is there a strict 24-hour lockdown for an exit sign? If the building's power is on, shouldn't the sign just work immediately?
Well, what's fascinating here is the massive gulf between functioning and compliant.
Okay, how so?
Yes, if you connect the building's AC power, the internal LED lights will illuminate. But an exit sign isn't a smartphone, it's a life safety device. So the normal operation of an emergency light isn't just glowing when the building has power.
Right.
Its true operation is its ability to survive an outage. Inside that plastic housing is a specific emergency reserve. It's a 3.6-volt, 1,000 milliamp hour battery.
So it's essentially a tiny, dedicated power plant just waiting for a crisis.
That is the perfect way to look at it, yeah.
Yeah.
Out of the box, that 3.6-volt battery is completely depleted. So if an electrician installs this unit, flips the breaker, sees the red light come on, and signs off on the inspection 10 minutes later, they have just created a massive hidden liability.
Because if a fire breaks out an hour later, the building loses power, and that battery hasn't charged.
Precisely. That internal battery hasn't built up the capacity to keep those emergency LEDs illuminated for the legally required duration, which is usually around 90 minutes.
Wow.
Yeah. Bypassing that 24-hour wait means the installer isn't just making a lazy mistake. They are legally creating a trap for the next power outage. The device is fundamentally out of compliance.
Man, that reframes the whole concept.
Yeah.
You aren't charging it to turn it on, you're charging it to guarantee it won't turn off.
Exactly.
But how does a property manager actually verify that the power plant is ready?
I mean, the manual mentions a test button, but it doesn't really explain the mechanics of what pressing that button does. The test button is brilliant in its simplicity, honestly. When you press and hold that button, you aren't just sending a signal to a computer chip. You are physically interrupting the main AC power flowing from the building into the circuit board.
Wait, really?
Yeah. You are artificially simulating a total building blackout right there in the unit. So if the emergency LED lamps illuminate when you press it, you know that 3.6-volt battery is holding its charge and doing its job.
Oh, that makes total sense. And there is a serious warning right below that about relamping, like replacing the bulbs.
Right.
It strictly warns that using non-specified LED lamps can cause transformer damage or create unsafe conditions.
Yeah.
It really underlines that this isn't just a generic living room lamp where you can screw in whatever 60-watt bulb you found on sale at the hardware store.
No, not at all. It is a closed, highly calibrated ecosystem. The internal transformer is designed to handle a very specific electrical draw from those exact factory LED lamps. If you introduce a different variable, say a bulb that draws more current, you risk overheating the internal components. Or worse, draining that life-saving battery twice as fast during a real fire.
Wow. But, I mean, an exit sign with a perfectly charged battery is useless if it falls off the wall when someone bumps into it in the dark.
Very true.
Which brings us to the physical reality of where this hardware actually lives.
Hmm.
The manual lays out a series of safety instructions for placement, and honestly, they sound incredibly defensive.
Well, building compliance is entirely defensive. You are essentially designing against worst-case scenarios and, frankly, human nature.
It really reads like it.
Yeah.
Rules 1 through 3 dictate no outdoor use. Equipment should be mounted securely in locations and at heights where it will not be readily subjected to tampering by unauthorized personnel. And do not mount near gas or electric heaters.
Right.
Are we treating an exit sign like it's guarding state secrets?
Well, think about this from the perspective of a property manager. How predictable are humans moving through a commercial building?
Not very.
Exactly. People carry tall ladders down hallways, they move large furniture, and, high schoolers love to jump up and try to slap the tops of door frames.
Oh yeah, they absolutely do.
So if an exit sign is mounted too low or with cheap wall anchors, it becomes vulnerable to all that accidental and intentional impact. If the housing cracks or the faceplate falls off, the optical clarity of the sign is completely compromised.
Wait, what about the rule prohibiting mounting near gas and electric heaters? I could get not wanting to melt the plastic, but is a standard hallway heater really that dangerous?
It goes right back to the chemistry of the device. Batteries are highly sensitive to extreme temperatures.
Oh, right.
So if you mount an emergency light right above a powerful gas heater, that constant thermal drafting will bake the internal electronics over time. It degrades the chemical integrity of that 3.6-volt battery.
Wow.
Yeah. So when the power finally does go out 3 years later, your 90 minutes of emergency reserve might suddenly become like 9 minutes.
That is wild. So placement isn't just about visibility. It is literally a chemical preservation strategy.
It really is.
And to enforce all of this, the manual relies heavily on Rules 6, 7, and 9. It dictates that you must disconnect AC power before servicing, you must consult local building codes for approved wiring, and any service on this equipment should be performed by qualified personnel only.
For a property manager, those specific phrases aren't just polite suggestions from the manufacturer. They are the legal bedrock of building safety.
I actually wanted to stop and linger on this because it hit me while reading this. Manual is basically a legal shield, isn't it?
It absolutely is. Qualified personnel and local building code mean that if an incident happens, if the building burns down and the signs fail, the insurance investigators, the lawyers, and the fire marshals are going to demand a paper trail.
Do one of his seats.
Exactly. They are going to look for documentation proving a licensed electrician did the work according to this exact sheet of paper. If a building owner just had their untrained nephew wire it up to save a few bucks, the liability is entirely on them.
That completely raises the stakes. This single piece of paper could literally determine who goes to jail after a catastrophe.
Yep.
So, assuming the licensed electrician is on site, the location is locked in, and it's safely away from any heaters. Let's move to the physical architecture of getting this thing onto the wall, or actually the ceiling.
Right, there are two options.
Yeah, the manual splits the mounting process into two distinct paths, ceiling mount and wall mount.
And the mechanics of the mount depend entirely on the architecture of the corridor. You might have, say, a glass wall preventing a flush mount, which forces you to go to the ceiling. But both methods utilize a standard J-box, and 20-inch jumper leads to bridge the gap between the building's wiring and the unit.
Let's actually define that for someone who hasn't done electrical work. A J-box, or junction box, is that metal or plastic square embedded in the drywall, right? The one that holds the raw, live wires coming from the building's grid.
Correct. It safely contains the electrical connections. And those jumper leads are simply extra lengths of wire that give the electricians some slack to work with while they are balancing on a ladder.
Right, so if you are doing a wall mount, the manual tells you to remove the back plate of the exit sign, physically knock out the necessary holes, which they call knockouts, and snap the housing directly to the back plate, flush against the wall.
Yeah, those knockouts are pre-scored circular sections in the plastic mold. You literally take a screwdriver and punch them out.
Okay.
It allows the electrician to customize the plastic shell to route the wires exactly where they need to go, depending on where the J-box is located in the wall.
But if you were doing a ceiling mount, gravity is working against you. The instructions say you have to bypass the flush mount, fasten a separate canopy accessory to the J-box bracket, remove a specific canopy hole cover on the top of the unit, and then snap the housing to that canopy so it hangs down.
It is a very modular design. It lets a single electrician carry one type of box and adapt it to dozens of different architectural quirks in a single afternoon.
But so, what does this all mean? Because here is where my confusion kicked in again, and I really need you to explain the underlying logic. It feels like an adult Lego set,
It kind of is.
but for both the ceiling mount and the wall mount, there is a shared crucial instruction. It's step 6 in both lists. It demands, in bold terms, connect battery only after continuous AC power could be provided to the unit.
Yeah.
Why is connecting that tiny 3.6-volt battery essentially the very last technical step? If I'm an electrician, wouldn't it be vastly easier to plug that internal battery into the circuit board while the unit is sitting flat on my workbench before I'm 10 feet up a ladder, snaking wires through plastic knockouts?
Well, from an ergonomic standpoint, yes, doing it on the workbench is much easier. But if we connect this to the bigger picture of how the logic board operates, doing that would completely sabotage the unit before it even touches the wall.
Wait, how?
Think about the sensory mechanism inside this device. How does it know when to turn on the emergency lights?
It senses that the main AC power from the building has been cut off.
Right. So imagine you are sitting at your workbench. You plug that 3.6-volt internal battery into the circuit board. The brain of the exit sign immediately wakes up.
Okay.
It looks around for incoming 120-volt AC power from the wall, but it's sitting on your workbench, so it doesn't find any.
Oh, I see it. The sign instantly thinks the building is currently experiencing a massive power outage.
Exactly. It immediately fires up the emergency LEDs. So while you are climbing your ladder, trying to align your canopy bracket, and snaking your jumper leads, that essential emergency battery is actively draining in your hands.
Wow.
Yeah, by forcing the electrician to establish continuous AC power from the building first and connecting the battery last, the manual guarantees a foolproof sequence. It ensures the battery's integrity is preserved so that the crucial 24-hour charging cycle can begin from a healthy state.
That is an incredibly clever piece of design. It utilizes order of operations as a literal safety mechanism.
It really does.
And once it's up, step 7 is to remove the proper chevrons as required. For anyone listening who doesn't know the terminology, the chevrons are those little directional arrows on the side of the word exit. They pop out the left or right arrow depending on which way the stairs actually are.
It's a simple mechanical step, but obviously crucial. I mean, in a smoke-filled room, pointing people into a broom closet instead of a stairwell is catastrophic.
So the unit is physically mounted, the battery sequence is correct, the arrows point the right way. Now we enter the true domain of the veteran electrician, the nervous system of the device. The manual provides a wiring diagram that is deceptively simple but incredibly strict.
This is where compliance meets raw, dangerous voltage.
Yeah. The diagram explicitly details the color coding. The red wire is strictly for 120-volt, 277-volt AC input. The white wire is designated as the common or KOMM wire. Let's break that down because most of us only deal with standard 120-volt wall outlets in our living rooms. Why is an exit sign dealing with 277 volts?
Well, in large commercial buildings, lighting circuits are often run at 277 volts rather than the standard 120 volts you use for your TV or toaster.
Oh, really?
Yeah. The higher voltage allows the building to run far more light fixtures on a single circuit without tripping a breaker. But it also means that the wires carry significantly more energy.
So it's the difference between a garden hose and a high-pressure fire hose.
That is a great analogy. If you wire a 120-volt component into a 277-volt line, the pressure blows the system apart. The rigid red and white designation ensures that any future electrician who opens that junction box immediately understands the voltage pathways.
That makes sense.
And the white common wire acts as the vital return path, allowing the electrical current to complete the circuit back to the breaker panel.
The manual also specifically states that any unused wires must be capped with enclosed wire nuts. What happens if an installer just ignores that and leaves an unused wire dangling?
That is how electrical fires start. An uncapped live wire can easily ground out against the metal junction box or arc to another component. That causes a catastrophic short circuit, destroying the unit and potentially igniting the plastic housing.
Okay, so you have this web of red and white wires tucked inside this plastic box, alongside yellow and blue wires if you are hooking up extra remote floodlights.
Right.
And this brings us to a physical warning in the manual that honestly blew my mind. Rule 10 states, make sure wire terminations are secure and leads are properly tucked in appropriate wire channels. But then it adds this incredibly specific warning about routing the wires carefully. It says, make sure to keep all wires out of the way of the exit legend so there are no shadows.
That is a detail that 99% of people would completely overlook when thinking about electrical work.
Here's where it gets really interesting to me. I'm picturing the inside of this light casing like a shadow puppet theater. Amidst all this talk of 277-volt fire hoses, short circuits, and transformer damage, a literal shadow is treated as a major safety hazard.
It is a phenomenal example of human-centered safety design. You have to anchor this back to the property manager's ultimate goal, providing absolute clarity during chaos.
Go back to our scenario from the beginning of the show. The dark, smoky corridor.
Picture it. The fire alarms are screaming, the sprinklers are going off, the adrenaline is peaking. The only source of illumination is the internal LEDs of that combo unit firing through the red or green plastic faceplate.
Yeah.
If an electrician was careless and just draped a stray red or white wire directly across the inside of that faceplate, that wire is going to cast a sharp, dark line right through the illuminated letters.
Oh, wow. It could cross out the E or obscure the directional chevron.
Exactly. And in a life or death situation, a partial shadow over the word exit could cause a split second of hesitation for someone trying to escape. They might second guess if it's really an exit, or they might misread the direction of the arrow.
That split second matters.
It really does. The manual treats a shadow as a hazard because cognitive load is a very real danger in an emergency. You want the human brain to instantly recognize the safe path without having to solve a visual puzzle through the smoke. Properly tucking wires into their dedicated channels isn't just about neatness, it's about preserving the optical purity of the sign.
Optical purity. I love that phrase. It really reframes the whole installation process. It isn't just about making sure the electricity works. It's about making sure the human response works.
Every single step in this manual, the 24-hour battery charge rule to guarantee survival, the strict avoidance of heaters to preserve battery chemistry, the foolproof sequence of connecting the power before the battery, and the careful routing of high-voltage wires to avoid shadows is entirely focused on removing points of failure.
It really makes you step back and marvel at the unseen layers of our built environment. A simple piece of plastic on the wall is actually a finely tuned system. It requires an intense order of operations. It requires deep voltage awareness from a qualified electrician, and it requires literal aesthetic care to prevent shadows from confusing us when we are most terrified.
It is the definition of meticulous engineering disguised as something ordinary.
It really is, and I think that's the big takeaway for you listening today. The next time you are sitting in a doctor's waiting room, or walking down a long hotel hallway, or finding your seat in a dark movie theater, take a second to look up at the exit sign. You won't just see a red piece of plastic anymore.
No, you won't.
You will know about the hidden 3.6-volt battery quietly standing guard inside. You will know about the strict 24-hour waiting period that authorized it for duty. And you will know that somewhere, a licensed professional carefully tucked every single high-voltage wire into a specific channel, just to make sure the way out was perfectly clear for you.
It completely changes the way you navigate a building, and honestly, this raises an important question to leave you with.
What's that?
If a single wire casting a shadow inside a plastic box can be classified as a critical, life-threatening safety hazard, what other microscopic, invisible design choices are secretly operating in the background of our everyday environments, quietly keeping us alive without us ever noticing?